Our next topic is emulsion. Emulsions are colloids in which liquids dispersed in liquid. I studied it earlier. So liquid colloidal systems or liquid dispersed in liquid, that is emulsion. There are two types of emulsions: oil in water type and water in oil type. Two types: oil in water type, oil dispersed in water; water in oil type, water dispersed in oil. These are the two types of colloids. You know, water and oil, they are immiscible. So for making of emulsions, an emulsifying agent is needed. Emulsions of oil in water are unstable and sometimes they separate into two layers on standing. So if you want to prevent it, you have to use emulsifying agent. What is an emulsifying agent? It is the third component which is adding to stabilize an emulsion. That is an emulsifying agent. For the stabilization of an emulsion, a third component called emulsifying agent is usually added. So here we have two types of emulsions. Oil in water type emulsion. Here dispersion medium is water and dispersed phase is oil. In order to identify oil in water type emulsion, it is soluble in water. That means we can dilute it by adding water, oil in water type emulsion. So can you say milk? Is it an oil in water type emulsion or water in oil type emulsion? Milk can be diluted with water. We can dilute it with water, so surely milk is an oil in water type emulsion. Water in oil type emulsions cannot be diluted with water. An example is cod liver oil. Cod liver oil is an example for water dispersed in oil type emulsion. Some examples are emulsifying agents. The principal emulsifying agents for oil in water type emulsions are proteins, gums, natural and synthetic soaps, etc. Oil in water type emulsions are stabilized by proteins, gums, natural and synthetic soaps, etc. And water in oil type emulsions are stabilized by heavy metal salts of fatty acids. Heavy metal salts of fatty acids, or metal salts of long chain alcohols, or we can use lamp black. These are the emulsifying agents for water in oil type. Here in this, you can see emulsions can be diluted with any amount of the dispersion medium. So oil in water type emulsion can be diluted with water, and water in oil type can be diluted with the oil. These emulsions shows the properties of colloids. The emulsions are negatively charged. Usually, the emulsions are negatively charged. That means the liquid particles dispersed are negatively charged. So it is possible to coagulate or precipitate by the addition of electrolytes. We can precipitate or coagulate emulsions by the addition of electrolyte. They also show the properties of colloids such as Brownian movement, Tyndall effect, etc. Then in order to in order to destroy the emulsion, simple heating is enough. When you heat it or when you freeze it, the separation of the two liquids will take place. Or by the centrifuging, the liquids can be separated. Now the uses of emulsions and colloids. We can see colloids around us. Here some examples are given. Blue color of the sky. It is due to scattering of light in the atmosphere. In the atmosphere, dust particles are dispersed. These dust particles will scatter the light. Therefore, only blue color can come to our eyes. Therefore, sky appear in blue color. Other colors of high wavelength will scatter by dust particles. We can identify a lot of food articles around us, which are colloids. Example, milk, already we mentioned, emulsion. Milk is an emulsion. Butter, halwa, ice, creams. All these are examples of emulsions. Sorry, colloids, not emulsion, emulsion. For emulsion, example is milk. Now, blood. Blood is a colloid. It is colloidal solution of an albuminoid substance. We can prove it by keeping alum on wounds. When you keep alum on wounds, the blood will be coagulated and further bleeding can be prevented. After shaving in barber shops, they will use alum, that is to prevent bleeding. So from this it is very clear, blood is a colloid that will undergo coagulation with the in presence of alum or in presence of ferric chloride. Formation of delta, another example. Here in the figure you can see a delta. It is a delta, which has the shape of Greek letter delta. Therefore the name delta. Here a river is joining with the sea. At that point, you can see the formation of the delta. River water contains a lot of dispersed particles. There may be clay, mud, etc. That dispersed particle, when meets seawater, it contains a lot of electrolytes such as sodium chloride. Because of the presence of sodium chloride in seawater, what happens? Coagulation of the dispersed particles in river water will take place. Gradually, such a delta will develop there. Now, in the pollution control, we can use the coagulation property of colloids. Electrical precipitation of smoke. Here you can see the figure. It is quarteral precipitator. You can see it here. Quarteral precipitator. Here you can see an electrode is present. We can apply high voltage. And the smoke is a colloid, you know. Smoke is a colloid. Carbon particles are dispersed in air. Carbon particles or arsenic compounds, dust, etc. in air, dispersed in air, all together form smoke. And these smoke particles, carbon particles are charged. And when you apply high potential here, the charged particles will be neutralized. Charged particles will be neutralized in the electrode and that will be precipitated. So carbon particles, dust, etc. will be precipitated here, and only the gases free from carbon particles will go out. Thus we can control pollution. Cotral precipitator. Another important application in purification of drinking water. Drinking water contains a lot of dispersed particles. In order to remove this dispersed particle, the undissolved solid particles can be removed by filtration, but the dispersed solid particles cannot be removed by filtration. So in order to remove them, we will use the principle of coagulation. Alum is added to water to coagulate the suspended impurities. In your alum contains Al3 plus ion that can neutralize the colloidal particles, and that will be coagulated or precipitated, and it is easy to remove. These colloids are using in medicines. Here some examples are given. Argyro is a silver sol used as an eye lotion. Colloidal antimony is used in curing Kala Asar. Kala Asar. What is Kala Asar? Karimbani. Kala, black. Asar, fever. Colloidal gold is used for intramuscular injection. Milk of magnesia, which is an emulsion, is used for stomach disorders. Antacid, we will use it as an antacid. And this colloids can be, or the coagulation can be used for in the leather industry for tanning. Animal hide, which is colloidal in nature and positively charged particle, contains positively charged particles. When it is soaked in tannin, tannin contains negatively charged particles. Mutual coagulation will take place, and thus hardening of leather is possible. So tanning is an example of mutual coagulation of two colloids. Animal hide is a colloid, tannin also a colloid. Animal hide positively charged, tannin negatively charged. In rubber industry, rubber latex is colloidal solution. When we add formic acid to it, coagulation of rubber latex will take place. That will be precipitated. In cleansing action of soap, we explained micellar formation. That is very important. In photographic plates and films, now we are not using it because it is the digital era. But in earlier days, in photographic plate, we used the colloids. Usually we used a colloidal solution of bromide salt to make silver bromide to make photographic plate. For the production of paints, inks, synthetic plastics, rubber, graphite, lubricants, cement, etc., we are using colloids. So industrially, it has a lot of applications. By this, the chapter is over, and in the next Friday, we can conduct an examination on this chapter. If you have any doubt, you can ask it in the classroom or through WhatsApp. Okay.